So here's a nice little scenario for us. Because the moon has no atmosphere, a falling object on the moon encounters no air resistance. In 1971, astronaut David Scott demonstrated that a feather and a hammer fall at the same rate on the moon. The position function for each of these following objects is given by S of t equals negative 0.81 t squared plus 2, where S of t is the height in meters and t is the time in seconds. What is the ratio of Earth's gravitational force to the moon's gravitational force? Well, we have to just know, they don't tell us, but at this point we should all know that on Earth, it's going to be 9.8 meters per second squared. That's the acceleration due to gravity on Earth. So let's look at S of t for the moon, and let's say what's the acceleration due to gravity on the moon. And we can find that by just taking the derivative. Because if this is the position function, we can take the derivative to get the velocity. So we just use power rule, bring the 2 to the front. 2 times 0.81 is like 2 times 81, so it's like 162, but more like 1.62 t. And then the derivative of 2 is just 0. So that's our velocity. And then very simply then to find the acceleration, we take the derivative again, and we see that it's just negative 1.62. Negative 1.62 meters per second squared. And it's just negative because it's going down, and that's why in reality this is also negative 9.8. So for now, we know the moon's acceleration, we know the Earth's acceleration. What is the ratio of the Earth gravitational force to the moon? So that's 9.8 to 1.62. We just have to do that division. I guess we could just whip out a calculator for that. I don't know why numworks isn't stored over there. And isn't that 6? Isn't that the idea? That 9.8 divided by 1.62 is, 6, roughly. 6.05. So that means the gravity here on Earth is roughly 6 times stronger than the gravity on the moon, which is why they say you weigh 6 times more on Earth than you do on the moon. Because also, I think the mass of Earth is 6 times more than the moon. Or that's by square roots, right? So is it 36 times more than the moon? That makes more sense. But anyway, that's not what we're here to talk about. We're just here to talk about the gravity. So we found the acceleration by taking the derivative twice. We already knew the acceleration from Earth, and so we just found the ratio.